Hey everyone, it's Joe and Isaias here. And during a hero call the other day, we had a really interesting idea that led to some cool code here. So we do everything we can not to have sleeps in our code, right? Because it's just usually not good. But what gets difficult is clients' computers operate at different speeds depending on how much load they have. And so sometimes you'll set a sleep to, let's say, 1 second, but it works great on your computer, but on their clients, they need a longer sleep. And so what we would normally do is just say, okay, well, we'll set it all for everyone to a longer sleep because that's what we have to program for. But what we thought was, and it kind of came up where I was like, how could we auto adjust the sleep based on the load or the capabilities of that computer? And that way, if I have a better computer, I'm not waiting around for the longest sleep, right? So
Yeah, exactly.
I'm just going to walk through. So I thought this was brilliant, as it's like, I honestly, to say it, I didn't really even understand what it was I'm like, it works. That's all I care about. Um,
Right. But again, this is not the best solution. It's just a solution, right?
to
So
start.
the idea here is, right, at least something to get us done. So in this piece of code, one of the pieces of code that we had.
Let me interrupt you just for a second. Clipster, by the way, is a great way if you want to have hot strings or hotkeys for pictures or for HTML. Clipster is
Right.
a library we created that allows you to be able to send those with a keystroke or whatever. So sorry.
Right. No worries. So the point here is that part of what we do is that we save your clipboard, whatever was there before you sent the text. It goes ahead and pastes whatever it's supposed to paste. And then after a while, it restores your clipboard. Now, here's the problem. Between pasting and restoring your clipboard, some programs take a little time processing the paste. And if the computer is under load, the time between pasting, processing the paste, and restoring the clipboard might have passed. And let's say that you want to paste the string Isaiah, your name or whatever. If you send the paste, but the program didn't take it, then instead of pasting the string that you had, it would paste whatever you had before. And that was the annoyance, right? And so the problem here is 500 milliseconds, perfect for my computer, maybe not when it is loaded, or maybe it would in your computer is different. So that's what the problem is, this particular slip. During the hero call, you were saying like, how could we even do this? And I said like, hey, the only thing that we have to do is measure what the time, the load on the computer is at that time. It doesn't matter if it is an accurate measurement. I just need to know what the difference is. I came up with an idea. In the help file, we have this query performance frequency example. This is a thing that is very precise. It queries in milliseconds, right? Well, below milliseconds, it is fractions of milliseconds is what it takes. And if you start a counter here, do an action and get another counter, so you get a counter before and a counter after, you can have the difference between the two, and you can tell how long it took to do this. In my case, I just said, hey, let's loop 1,000 times. Let's just assign a variable 1,000 times. When your computer is at full speed, this is performed in like 2 milliseconds, 1 millisecond, whatever. But when the computer is under load, or if it is slowed down for whatever reason, some other program is loading, that same task will take longer. It would sometimes do 13 milliseconds, 14 milliseconds, sometimes 300 milliseconds, and so on and so forth. So the idea is this function performs the check, how long it takes to do this basic task in this computer at this particular point in time, and then it would return back in milliseconds what it is. So let's test it. Let's look at it. So let's do this. Let me just run it. And you will see what I mean right here. So I'm going to call the function, and I will get a number, 0.07. Yeah, okay. But if I run it again, it might be a different number. You see that this time was 0.1. So this is exactly, let me not multiply it by 1,000 so that you see the numbers as they are. 5.17 milliseconds is what it's saying there. And I could actually even floor it so that I could just get a number. Oh, well, no, let's not floor it. All right, so 3.0, 2.8, and you can see that every time I run it, the numbers might be different. And depending, if I run something that loads my computer now, that number is going to go up. And that's great, because that means that my sleep delay is changing every time. So this is my frequency. I get that number. And instead of having a fixed number, 500 in this case, I could now go ahead and get delay time. So I will get this number, and I will multiply that by 1,000. That is in seconds. And the reason why I'm multiplying here is because I am multiplying down here, right? But if I don't do this, if I don't multiply that, then I don't have to multiply up here. And I will get a delay in seconds. So this would give me 5 seconds, 3 seconds, and it would change. It would flip between. And if your computer is completely loaded at the moment, it might say sleep 10 seconds. In this case, we like it because we don't care how long it takes for us to restore the clipboard. Most of the times, you don't need the clipboard right away. So if I wait 5 seconds, 2 seconds, that's totally fine. But in certain situations, you might need a delay between certain times. You can clamp it and do kind of like an upper bound and a lower bound. And that way you don't have like more than 10 seconds, for example. I don't want a 10-second delay on my program, right?
So we probably should add some parameters like that to say, hey, that's the maximum, right? But it's a very cool approach, because again, for us, we are constantly creating tools that we give to other people, right? And running their computers in different systems with different loads on different programs. And all those things affect how fast something gets done. And so this have a little auto adjustment done to it.
I want to, if we have a delay time on milliseconds, which is what I want, I will tell the sleep to wait for that amount of seconds,
right?
Depending on the computer, basically.
Right. So I hope you enjoyed that. This and other topics like this are what we talk about in the hero calls all the time. So 3 hours a week. Of course, you can also just watch the reruns if you can't attend the meeting, but hope you enjoyed that. And thanks for watching. Cheers.